yield strength. And this is listed as KSI, and I said that this is in the steel manual. And this yield was determined, by the way, from the stress strain curve for steel. As you know, the stress strain curve for steel, this is sigma and this is epsilon. So the stress strain curve actually it is like this. This is the actual stress strain curve for steel, but the design one is a little bit different. And the design one is the red one. So basically it is the same linear portion. But when we come here, we take this, and this is a design one. This is a design as far as the, so this here, this value here, we'll call it F sub y, the yield. Because actually we have two yield points. Okay, one, we'll call it upper yield point. If you look to this knee here, and enlarge it, you will find that we have the following. We have upper yield point and lower yield point and so on. So this is the upper yield point and this is the lower yield point. So this is the upper yield point and this is the lower yield point. In design, we take this. We ignore the upper yield point. Because the upper yield point is a temporarily and it doesn't last too long, and it is higher than the lower yield, so it is conservative. We are using, so the values listed in the steel manual, it is based on the F sub y, which is the lower yield point. This is for a material that has a well-defined yield point. This is type of steel, like low carbon steel, like A36 steel, for example. A36 steel has a well-defined yield point. It has upper yield point, lower yield point, and the code, as I told you, consider this as my F sub y, the lower yield point. We ignore the upper yield point. So, but if we have a material or steel does not have a well-defined yield point, they came up with a definition for the yield strength. For example, as the carbon content increases, you will find that the shape of the stress strain curve is a little bit different. This is epsilon. So basically, we don't have a well-defined yield point. The linear portion, by the way, before I leave the linear portion here, the slope of this line, it is E, the modulus of elasticity for steel, which, as you know, it is 29 million or 30 million. So either one of them, if it's not given to you, I will take it 29 or 30 million, and you will get the same answer, essentially, because the difference is very small as far as when you using these two numbers will give you the change in the answers will be very small. So either 29 or 30 million PSI, both of them could be used. So which is the slope of the linear portion. So if you have a material or steel material or steel with high carbon content, you'll